Dielectrics are materials that are put in between the plates of capacitors. So it's put in between the plates, and the material can be pretty much anything. It can be paper, you can have plastic, mica, which is a type of rock that you can cut into very thin slabs. And there is also, for a type of capacitor, it's a form of rust, and that's for electrolytic capacitors. But you have to be careful when you're using electrolytics, because these are polarized, meaning that you can only hook the battery a certain way to these capacitors. If you hook it the incorrect way, the capacitor becomes a little firecracker, and it's not a good smell when they go off. It creates this nasty foam, and believe me from experience, I didn't do it, a kid in my class did years ago. It smells nasty. It's this nasty looking foam, and it's carcinogenic, meaning it will cause cancer. So definitely don't want to hook these up the wrong way. But these are huge. They're used a lot in circuits. So let's take a capacitor. We're going to hook it up to a source. And our source has some potential V0, and our capacitance we're going to call C0, and we'll have some charge Q0 magnitude on each plate. So our capacitance C0 is equal to Q0 over V0. And now let's take that same circuit, we'll have V0 here, and now we're going to take and put a dielectric in between. So we're going to put a dielectric in here. And what's going to happen is that the amount of charge that collects on the plates is going to increase by some constant . So now, what's our C value, our capacitance value, going to be? So our new capacitance, well, that's just going to be equal to Q over V. And our new Q is now K Q0 over V0. And Q0 over V0, well, that was just C0. And we get our new capacitance has been increased by the value of the dielectric constant. So it's K times C0. but the amount of charge that we've put on the plates of the capacitor has increased also by a value of K. Now let's take, for a second example, and we're going to have our charge Q naught on the capacitor. And again, we'll have C naught is equal to Q naught over V naught. And now let's cut the capacitor. So now I have just the capacitor, and it's going to have some potential V naught across it. I'm still going to have Q naught on the plates. And now I'm going to add a dielectric. Well, the charge can't change. There's nowhere for it to go. And the only thing that will change is that our potential, it will decrease by a value of K. So if I go to calculate my new capacitance, I will have Q over V. That's just going to be Q naught over V naught over K. And that's just going to be equal to K times C naught. So in both cases, adding in a dielectric has increased the capacitance of the capacitor. And this is useful because a capacitor that you would want to hold a fairly large capacitance is going to get increasingly larger if you're using air. But I can decrease the size of the capacitor to get the same capacitance, and then you can fit it on circuit boards. It becomes more manageable that way. So dielectrics are very important when we're looking at designing components, and especially if we need to fit certain sizes. We can get the dielectric constant to be very specific for the values and the component sizes that we want.